Good afternoon. Good afternoon. Good afternoon. Good afternoon. Good afternoon. Good afternoon.
Good afternoon.
Good afternoon. I'm very well, thank you. And your good self? Most wonderful good afternoon. Good afternoon. Good afternoon. Most wonderful good afternoon.
Oh my God.
Good afternoon. Good afternoon. Does the code work? Yes. That's always my sort of It's almost a catchphrase, isn't it? Does the code work? Yes. Oh, thank God for that. Good afternoon. Good afternoon. Good afternoon. Take the recording notice off. Good afternoon. 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 I have to get used to that it says Presto, not Moodle. Remember from the first year where I had Moodle and then the attendance code? But now with Presto, it is sort of the association of pesto.
I was thinking pizza actually for some reason.
Yeah, it's, every time I write that, I think, oh, tonight I'm going to have pasta with pesto. Have a quick look, and then we get started. Coming? No. Okay, let's get started. A most wonderful good afternoon, ladies and jelly beans. And a very warm welcome. It's really lovely to see you guys again. I missed you last year. Did you miss me? At least you're honest. I was told that the code works, so please do register your attendance. You know how to do that, I assume. You have done that the whole term. Because otherwise you get a stroppy email from the attendance engagement people and your supervisor. I was told that this is the only session that you have on a Friday today. Really? There's no pressure for me then, right? I have to make it worth your while to come in. But ouch. Okay, now let's see what we can do. This is for, which module is that? That is for, oh yeah, it's for the research skills module, for the project module, right? So you are doing a project, am I correct? Assuming? and you have sort of already started more or less. You had meetings with your project supervisor? Yeah, everybody had meetings so far, virtual or in person, and you know what kind of project you're doing. Can I just have a quick show of hand? Who is doing a lab-based project? Hands up. Okay. Who is doing not a lab-based project? Hands up. Okay, who is not doing a project? Okay, good. That was just a check. Okay, so quite a few people doing lab-based projects. And of course, they are quite exciting. Also, the non-lab-based projects, they can be quite exciting. And what I thought, what I want to do in this session, I pray we don't need 2 hours. I hope that is okay with you. What I would like to do with you is, in the first part, I will give you a sort of a little bit of a push in terms of research skills that hopefully you find useful to apply for lab projects, but also non-lab projects. So we will briefly talk about how to research a problem, how to do a little bit of literature search, how to document that, because you have to basically document all the steps that you're doing, whether you do a lab or non-lab project. And in the second part, I would like to introduce you to some software called R and R Studio. Who has experience with R? Hands up. One. Oh, wow. Do you like it? R is the dog's knee. R is fantastic, and R can do things that where Excel, for example, in terms of statistical analysis, just simply waves its little arm and says, sorry, Excel can't do it. No, R will solve your problem. If you know how to tame the beast, there's a bit of learning involved, isn't it? Yeah. But otherwise, it is excellent. And I will give you the resources how you can actually get started with it. And it will be really useful for your project. Okay, so I have also set up a website for you. So if you scan this code, but I will also send out a Moodle announcement probably over the weekend with the links to these resources. This website is sort of meant as a sort of a little bit of reference for you. And it's actually not just for you guys. I also use this website with the Toastmaster students, and they said they found it quite useful because they are pretty much in the same position. They have to do a project, and they need to sort of understand actually what this entails. So let me see if I find that. Yeah, that's the website. That's the advanced research skills. And it has a number of topics included. So, for example, it puts a research in context. It gives you a little bit of idea, research, and ethics. And that is something that, for example, the people who are doing non-lab projects, where sometimes when they do dissertation projects, some people say to me, oh, I want to do sort of a survey of people, how they feel about, IVF or assisted dying or something like, I just make something up here, how they feel about it. And I don't know how your supervisor takes this approach, but my reaction is absolutely no. You're not doing surveys. Because a proper survey is pretty difficult to do, actually, the questions. And secondly, you have to have ethical approval for that. Even if you just ask people, what's your opinion? What's your opinion? What do you think about it? And if you record that in any way, then you need ethical approval. And ethical approval for this kind of research for working with human participants is not straightforward. So if you have planned in your research a survey of human participants, think twice. If you want to do that with dogs, that's fine, although I'm not sure how much you will get out of dogs. There's also something about study design, and that links quite nicely into the ethical research question, because if you, for example, want to look at in a clinical trial or related areas, if you want to say, right, I want to test whether a drug is efficient against, let's say, malaria, then obviously a good starting point would be to take people, half of your participants, they will get the drug, and the other half will get a placebo, right? And then you compare a certain outcome and say, yeah, does the drug work? But unfortunately, if you make a suggestion like that, any ethics commission will shoot you down immediately, because is it ethical to withhold the drug from one group of people and give it to other people? Absolutely not. So in a way, you can't do that kind of experiment. Good. Ah, good. Go away. Windows security. Yeah. However, if you design your experiment in an interesting or in the appropriate way, you can come up actually with a different way how you administer sort of the drugs, or how you test whether a drug is efficient. So it could very well be that in certain study designs, it is not you who makes the decision whether somebody gets a drug or not. You just simply check if somebody has taken the drug or not. And then you can use that for the analysis of your research. So there are lots of important concepts on this website. There are also some statistical tutorials, because believe it or not, you will have to do statistics at one point or another. And this is not just for the people who do lab-based projects. We want everybody, also the dissertation people, we want them to engage with data, with information. And for that reason, I think all the supervisors will agree with me, for a decent project, it is no longer accepted just to do a summary of a few papers or something like that. ChatGPT can do that for you, right? You just plonk a few papers into ChatGPT, and say summarize it, and it will come up with a more or less decent summary. And in previous years, lots of people were quite happy with that. Now it's no longer sort of, will not give you a very good grade for your project, because you have to engage with data. And that is what we do as scientists, right? Whether you do lab or non-lab project, we make claims. Drug A is more effective than drug B. Or we have cloned XYZ gene and expressed the protein. Just saying that doesn't cut it. You have to give evidence. You basically, when you do research, you have to give evidence about everything. Is drug A really better than, for example, a placebo? And even if you do just a dissertation project, you have to actually think about how you verify your claims that you make. And that brings me basically to the problem of research questions. So if you haven't recorded your attendance, here's the code, 263490. You need to find some research questions that you can quantify, that you can verify, that you can research. If you do a lab-based project, very often your supervisor will have more or less already made this decision for you. So, for example, you will look at bacteria on strawberries that will prevent the fungal infection of these strawberries. Is that something? Yeah? That I just heard. And there the question would be, to what extent can these bacteria prevent fungal infection? So you will get some data and then you can compare the data. But what if you have a far broader topic, have chosen a far broader topic? Many dissertation students or business plan students or communication students are in that position where they choose a topic, and now you have to do something with it. You have to break it down into something that you can actually make claims and you can verify. And when I started here about 30 years ago as a research postdoc, I had a conversation with the principal investigator with whom I worked, and it was before I actually started. So we knew about the project that I was doing, and he said to me, okay, good. The big picture is we want to cure cancer. So that's curing cancer. That is the umbrella term. What are you doing on Monday? And you think, what do you mean? And he said, well, you can't cure cancer on Monday. You have to break it down. So on Monday, for example, you start doing a little bit of bioinformatics and see what are relevant genes. So you probably have already chosen a wider topic, like strawberries and bacteria, or in your dissertation, you might have come to the conclusion, for example, I want to investigate novel therapies for the treatment of HIV. Sounds like a great project title. But now the big job starts, because now you need to think about how can I actually break that down into smaller chunks that I can actually investigate. Now, for dissertation students, at least for those who do projects with me, I suggest to them, try to find perhaps three questions that are actually researchable, that are quantifiable. So, for example, when we take this overarching topic, novel therapies in cancer research or HIV research or whatever, one of these questions would be what I just said previously. We could say, let's focus on a particular treatment regime and say, we want to investigate whether drug A is more effective than a placebo in the treatment of breast cancer. And then we say, what do we mean by effective, more effective? And we sort of then refine our question and say, well, with more effective, we actually mean that a certain cancer marker is reduced. Now we can rephrase this question and say, does drug A reduce the concentration of a certain cancer marker in a statistically significant manner compared to a placebo? And bang, what you now have is a really nice research question where you say, I'm going to analyze that. And that will score you very highly with your supervisor if you can do that. Now, very often, people say, how do I get started with questions like that? And there is something that is incredibly useful, which is called the PICO framework. And PICO can work for lab projects, but also dissertation projects. In fact, I use this PICO framework whenever I read a publication. Is anyone not familiar with PICO? Hands up. Good. Anyone familiar with PICO? Good. Excellent. So, what does PICO stand for? PICO is an acronym. The P stands for population. I stands for intervention. C for control. O for outcome. And sometimes there's also a T, which stands for time frame. Okay, what the hell? So, population. Let's stick with the HIV treatment. We want to investigate new therapies in the treatment of HIV. We might have a paper, or we might have a sort of an idea what we are going to investigate. So we, for example, say we want to investigate this particular problem, and we specify it for which population we want to do it. When you do clinical trials in biomedical sciences, this is the framework, because you have to specify everything. So the population could be, for example, men under the age of 25 in sub-Saharan Africa. This is the population that we are looking at in our analysis. It could be pregnant women infected with HIV. It could be, totally different example, it could be strawberries infected by a fungus, or if you have a lab-based projects. So the population specifies what are we dealing with. Intervention. This is fairly straightforward when we go back to our HIV example. Here we can say we want to check whether this new drug or whether this new drug regime, or if we are looking at several drugs, whether this works. This is what we are testing, the intervention. So that is what we hope to investigate. And we compare that against a control. So for example, somebody who did not get the drug. Or we look at other fruits. Do they get infected by the same fungi? Do the bacteria that prevent the infection work on other fruits as well? So that would be control. We need to be always absolutely clear about these things. What is it that I measure and how do I compare it? What is it that we actually collect in terms of data? What is the outcome? If I say, for example, drug A is more efficient than drug B or the placebo, yeah, but what does that mean, more efficient? And I said that before. More efficient could mean it suppresses a cancer marker or HIV marker or something, or reduces the virus load. It could also be, what else could it be? How else could I measure an outcome? What do you think? What other outcome could I measure when it comes to HIV? Reduction in?
Symptoms.
Reduction in symptoms. Very good. Yes, absolutely. What else? Something like survival time. Yeah. So in a way, it is more or less up to you what you measure, but it has to be a measurable outcome. Just simply saying, oh, it's more effective, then everybody says, yeah, how do you know? You need some data for that. And the time frame, sometimes it is included. The time frame is then, let's say, treatment over 12 months. Or in terms of survival, we can say mean time of survival until, death do us part or something like that. How long does it take for an event then to happen? Well, usually it's just a pico, and people are quite happy with that. If or when I read a scientific paper, I actually have a piece of paper next to me where I have pico down, because it helps me to focus in this paper what people did actually. What is the population that they looked at? What is the organism that they worked with? What is the system that they worked with? What is the protein that they worked with? What is the intervention? What did they actually measure in terms of, say, treatment or manipulation? What was the control? And what is it exactly that they measured at the end? And you can do that for basically any kind of publication that you look at. And it gives you a sort of a really nice summary straight away. What is the paper all about? What is PICO framework? Now, let's have a quick revisit of the, oh, bless you, of the outcome. Because I said we have to have data. It has to be quantifiable. And depending on the data that we get, we will have to apply different statistical tests, for example. And you all did the skills statistics, most of you at least did, back 2 years ago, long time since then. Have you done a lot of statistic testing in between? Hypothesis testing? No? T-test? Really? Blow me with a feather. Really? You didn't do anything like that? So you've forgotten everything? True? But be honest. If I say to you, what statistical test would you do if you had to compare two continuous data sets? What t-test would you? Oh, yeah. Okay, don't worry, because we have decided that in next term, when you are already sort of getting some data, be it lab or be it dissertation or other projects, I will run bi-weekly, fortnightly stats clinic where people can just come in or email me and say, I've got a problem. My response will be, me too. And how can I analyze that? And I can see if I can help you with that. Yeah. But it just highlights the fact that very clearly we need to do more data analysis with you guys during the entire degree program. Would you agree? Yeah. Okay, let's have a quick recap of data that you can get, because the data type that you have absolutely determines what you can do with it. So you could have, for example, dichotomous or binary data where there are only two outcomes possible. So for example, patient is dead or alive, or has disease or doesn't have the disease. And how you deal with that is very different to, for example, continuous data. Continuous data are measurements where there is almost an infinite number in between a data point and the next data point that you measure. So for example, height would be considered a continuous observation, because I could measure somebody and say, okay, they are 175 centimeters tall. I measure the next person, 176 centimeters tall. But in between the 175 and 176, there's an infinite number of numbers that I could, in theory, measure. And it is just limited by the resolution of my measuring tools. So it's almost infinite between them. I could measure 175.23876 centimeters, and so on. But we treat these data in a very different way from the dichotomous data or from ordinal data. Ordinal data are usually discrete data can have different categories, but there is an order to it. So for example, if you look at the medal table of Olympic Games, you can have gold, silver, and bronze medal. And each type is certainly different. Characteristic, and there is an order in it. You certainly want to have a gold medal rather than a bronze medal, bless you. So there's an order in it. These data are not continuous because there is nothing between gold and silver or silver and bronze. But how much they differ from each other is a sort of, is a gold medal twice as valuable as silver? Or 5 times, or 10 times? We don't know. So there's no defined sort of difference between the categories. Our data might be counts. So if I, for example, count bacteria on a plate, would the counts be continuous? Could the number of colonies on a plate be continuous? What do you think? Can counts be continuous? Number of colonies on a plate? Yes or yes? What do you think? What's your gut feeling? No gut feeling? Good. What's your gut feeling? Yes or yes? That's my GP who's trying to ring me. And you listen in on my diseases. No. Counts, of course, are discrete. They are not continuous. I either measure 150 colonies or I measure 151 colonies. I can't have 150.32 colonies unless I cut one colony straight through. But you know, we're not discussing that. So counts are discrete data, and discrete data need to be treated very differently to continuous data. Rates are very interesting. We are dealing with rates when we say discrete data per something, per time or per space. So when I said, for example, I have 150 colonies of bacteria on an agar plate, I can say 150 colonies per plate. That would actually be a rate. And rates, again, are very differently. Rates are very often, not always, but rates are very often show what is called a Poisson distribution. On the other hand, continuous data usually or very often show a normal distribution. And these are differences that are incredibly important when we do analysis of the data, when we say we want to test whether two rates, for example, are the same. We could measure growth rates, for example, where we say we look at the change in optical density per time unit. Now, that's an interesting one because we need to be careful. Are these discrete data the change in optical density? Probably not. So we have continuous data per time frame. And that, again, is a totally different beast. These data then are not Poisson distributed. They show some other distributions, which makes it quite interesting to analyze. Let's put it this way. So we need to be very clear about the data type that we get for our outcome. Now, let's say we apply this PICO and we have a good idea what our research question will be. Now, the next thing that we need to do, whether this is lab or non-lab based, is there anything in the literature that we can use as a starting point? And there's a very good chance, actually, that your project, whatever this project is, will have a little bit of background already been done. It's very unlikely that you come up with a totally new project. I doubt that. So what you need to do is you need to look at the literature. What is known about this particular problem? What is known about, for example, HIV infections in young men in sub-Saharan Africa? Because that is your research question. So you do a literature search. Have you done literature searches? Yeah. So PubMed, Google Scholar, Web of Science, things like that. So you put your research question, or you put your, what do you put into PubMed? Keywords. Good, keywords. Excellent. So you start with your literature research. And what you need for that is a search strategy. So you use certain keywords. You probably also use some filters. You might use Boolean expressions. You know what Boolean expressions are? Yep. So, and, or, something like that. So you come up with a list of keywords and filters. So you might say, for example, I'm only interested in young men and not pregnant women. I am only interested in HIV positive people in sub-Saharan Africa. I'm not interested in the same cohort, in the same population from Sweden. So what you define in your literature search is, amongst these keywords, you can also use mesh terms. Have you heard about mesh terms? These are medically related terms, and you find something about mesh terms on this website that I set up for you. So what you create is basically a list of inclusion terms and exclusion terms. So you say, young men, HIV positive, under the age of 25, in sub-Saharan Africa, and I want only the latest research, so I exclude all publications before 2000. That would be a very good search strategy because it is focused. Of course, you then need to record this strategy. You need to tell people what are my keywords that I used, what are the filters, how did I do this research, how did I get to the papers that I am using, for example, for my literature research. You need to document that. You need to document this decision process. How can you do that in an efficient way? Well, actually, when you do, for example, clinical trials, you absolutely must document how you actually sift through the huge amount of data in the databases, PubMed. If you put in HIV into PubMed, you get several thousand publications. But you can't read several thousand publications. You have to sort of whittle them down to a reasonable number. But how do you do that? Well, there is a fantastic scheme, which is called the Prisma flowchart. And I really strongly suggest that you use the Prisma flowchart when you do literature search to document how you ended up with these 5 research papers that you are actually looking at. Those students who do projects with me, for you guys, this is essential. I will mark you down if I don't see a Prisma flowchart in the material and methods part. I want to see the keywords. I want to see the inclusion and exclusion criteria. I want to know what filters you used, what databases you used, and I want to see how you actually decided on setting certain papers. And this Prisma flowchart is basically a sort of a document that tells you, okay, I identified in the first round, I found 9,340 papers. Nobody in their right mind will read 9,340 papers. So before you even screen, you can put in a filter and say, remove all duplicates. Very often, papers are cited in duplicates or triplicates or something like that. So here, we remove 4,325. And some of the, for example, PubMed will say, no, that's not a really good paper, so it will mark that. and it will remove 4,821. So of these 9,340, we have removed 4,821 and 4,325. So we've got 194 papers left. Of these 194 papers, what we can do is we can look at the abstract and just have a sort of a glance at the abstract. Usually abstracts are freely available. So I'll read that, and yeah, the word HIV turns up, but it's not, doesn't sound really like it's really interesting. Let's not worry too much about it. Let's forget that. Let's sort it out. That goes in the bin. So let's say we've got 124 that we sort out. 194 minus 124 gives us 70 paper. That might be of interest to us. And you see the numbers actually need to add up in this Prisma chart. If the numbers don't add up, that's very easy to check for me. I know that you have cheated, and I'll mark you down. But numbers don't add up. Okay, next one is I did not retrieve 53 of these 70 papers because they are behind a paywall. The university doesn't have a subscription, or I'm just too lazy to go to the library, although you wouldn't say that in your report. It could very well be that they are not in English, and you only read English, or you qualify in your keywords, and your inclusion criteria must be in English. It's a perfectly valid inclusion. No full text available, so we sort them out. We've got 17 left. And these 70, we look in more detail, and we say, okay, these are the papers that are really interesting. They are really of relevance. But there might be some papers that are not in peer-reviewed journals. It might be a sort of something in The Guardian as a report. Interesting, but it doesn't stand up to scientific scrutiny. So we would exclude that. Or the sample size is really small in these papers. Small sample sizes, difficult. Screws everything up when you do statistical analysis. Or there might be papers then that have been withdrawn in the meantime because they are not accurate. So we sort them out. Eventually, we end up with a number of manageable papers. So in this case, 6 papers. And these are the papers that we are working with. And that is perfectly legitimate to come to something like that. And we've got it nicely documented with this Prisma flowchart. So I really want people to think about it. Now, before we have a quick break, there could be something that is incredibly annoying that could happen to you, that will happen to you at one point. This is, you start with a fantastic research question. You then go into the literature and say, give me all the papers. You follow the scheme, and you end up with 0. 0 papers that you can use that have usable data in it. That's a bummer, isn't it? Because all your effort is basically for nothing. You spend days getting these stupid papers out. None of them gives you the data that you want. What can we do? I know you a little bit. So forgive me for a personal question. You want to know how to cheat? Yeah? You want to cheat? I tell you how to cheat. What you have done is you formulated your research question, then you troll through the literature and try to find the data that is relevant to the research question. And you didn't find nothing. What if you turn that around? What if you say, I have a vague idea of the topic that I want to investigate. Let's have a look what data is out there. Let's see if I find some interesting data tables or information. Then I look at the data and say, what question could I ask? You see what I'm doing here? I say, I've got the data, I've got the answer. Can somebody ask a good question, please? Because I've got already the answer. I've got the data. What question would fit the data? So in your research project, especially in dissertations, you can use this strategy. Don't tell anyone. But you can use this strategy and say, I've got some data. I've got some interesting data tables, for example. I've got, number of 50 patients. They are HIV positive compared to another set of 50 or 100 people HIV positive. One got a drug, the others didn't. It's not exactly the drug that I originally had in mind, but hey, it's a drug. So why don't I investigate this particular drug? I know already that the data are there. I even found the paper. So let's use this and ask the question. If you are doing a data analysis project, for example, with me, if you are unfortunate enough to do that, you will have a data set with lots of data, and your job will be to come up with questions that you can ask about the data. Now, later happen because in your research career, you will have set questions, but for, say, dissertation, I've got the answer. Let's think about a question that we could do, not the other way around. I have a question. Let's see if we are lucky enough to find an answer for it. Make sense? I suggest we have a 5-minute break, and then I will do a quick introduction to R and RStudio. Okay? Happy with that? As an example, here is does that make sense?
Right, so I'm just showing it for an example of a flowchart. So you mentioned keywords. Whereabouts do you what keywords?
You would say, for example, you would say the following three words were used. Well, in the flow chart, if you look at the flow chart, it doesn't really mention the keywords.
If you do accumulation of everything, sort of a
Yeah.
global view of your entire
Yeah.
research.
Yeah, it doesn't mention the keywords. It sort of says, the abstract didn't seem to be relevant. It assumes that you had already the keywords used and got the hits, and then you filter further.
Okay, so this is it. I can literally start my spreadsheet, record of all my keywords, record of number of searches, record of the ones that I actually read and mention.
Absolutely,
one,
absolutely,
and then at the end,
absolutely.
add them all together and come up with something like
Yeah.
that, and that would be okay.
Yeah. Sounds reasonable?
Oh yeah, as long as you start at the start,
Yeah.
I haven't done too much, so it's quite easy to reproduce. I had the keywords already. I just but I hadn't realised I needed the keywords for notes or how many actual, because I was just taking the hits that.
Yeah, but
match.
put them in, because that is what we want to see. We want to see it that it is documented. What
But
you have
obviously,
done.
you've got 6 at the end for that one. I'm going to end up with a huge number more than 6.
Right. This is predominantly for, I would say, for when you go into the data. If you have sort of background information, yeah, then you don't have to include them.
This is when I'm actually.
Yeah. If you just say, HIV is a retrovirus, you don't need to include that.
So that's just basic background.
Yeah, exactly.
So our
Exactly.
project proposal will
Yeah.
background
Yeah.
information.
Yeah.
But there's still going to be quite a few because I've already been making notes of all the different aspects I can consider.
Yeah. But the important thing is make it that you can document it, what you did.
Okay, yes, spreadsheet.
Yeah.
The example there with the second step.
Sorry?
With the example,
Yeah.
the second step, they've read there's 194 they found.
Yeah. Yeah.
That means that normal like 200 abstracts. Seems like a
Well,
Oh, often more than that.
yeah, sometimes you do.
What is this record to Marcus Minority of automation tools? What have you seen that?
I think that is sometimes in PubMed, where you say, I only want it in English.
So that's the advanced filters.
Yeah, exactly. Yeah. Not all will always apply,
Yeah,
but
just an example.
yeah, it's an example what it could look like. Sometimes people add more to this chart, depending on what they did with the data. Sometimes people take things out, yeah, and they say, okay, I was just simply too lazy to go to the library, so 50% I didn't look at. You wouldn't say that, but you would phrase it.
Nowadays, everything's online, or all the university hasn't built access to it, which is
You could say no access available.
For the ones with no access, is it worth going to the bioscience librarian and asking if they can?
Absolutely. If you think this is a really crucial paper.
There'd be a lot of time to make sure you get it early then.
Well, we used to have, I don't know whether this is still existing, we used to have what is called interlibrary loan. When you found a paper where you thought this is absolutely essential, then you could make a request to get a copy of that paper through the library.
You definitely can make requests, I know
Yeah.
that, but
Yeah.
I think.
Or alternatively, you go to London to British Library and look at whether you get it there. Some people have done that.
Well, okay, that would be probably £200 to.
How did you keep track of that amount of papers with like a spreadsheet or just literally a list?
Oh yeah, it would be just a spreadsheet. I mean, to be perfectly honest, I don't know any supervisor who will try to replicate, if there is even a flowchart in it, in
Make
your
sure
report.
that the numbers add up.
Good point. Good point. Very well made. Yeah. Makes sense?
Yeah.
Have you ever done anything like that?
No. First time it's ever been
Yeah.
mentioned.
Hang on.
You said for your students, this is going to be like absolutely necessary, expected, yeah. But say obviously because I have a different advisor, will they be like, if they see this, will they be like, why have you put that? Or will they still appreciate it? Will it still be, do you know?
Let me put it this way. I have not encountered a supervisor who says, what the is this crap?
Okay.
Yeah. They will say, oh, wow, never seen anything like that. Gets full marks.
So it's worthy of marks.
Absolutely.
Okay.
Let me put it this way. If it doesn't give you marks, you wouldn't lose any.
Yeah, yeah, of course.
Yeah.
Okay.
But if I am second marking, which you don't know,
Yeah.
then my first look is there a personal flow chart?
Okay.
Yeah.
Yeah. Okay. Would this also be okay for like in a lab project?
Yeah, absolutely. Because you do a lab, you do an introduction, so you can document what kind of, how you actually came up with the papers that you are citing. Very often in lab, however, it is, for example, if you say HIV is a retrovirus, that you would have a reference, but you probably would not include that necessarily here. This is more sort of when you get to papers that contain data that you're really working with somehow. Yeah.
So this would only be methods, not.
That would, a very good question is that where should that go into introduction or methods? This is a typical methods thing. So the Prisma flowchart is really for the methods. Should not be in the introduction. It should realistically not be in the results section. Okay, shall we continue quickly? Because I want to introduce you to this R and R Studio. The biggest hurdle that people have with R and R Studio is the installation. And before you try, no, it will not run on an iPad, unfortunately. It runs on Mac, it runs on Windows. Don't know whether it runs on Chromebooks or Linux. I haven't tried that, but Windows and Mac is absolutely no problem. You will be delighted to hear that the software is free. So you don't have to pay anything, and you can download it. And as I said, there is here is the QR code for installation instructions. You have to install R first, and then you can install the sort of the interface, R Studio. It takes a little bit of time to get used to it, but once you are there, you can do absolutely fantastic things with it. And I probably should not tell you that, but I do it anyway. You can ask ChatGPT to write the programs in R for you. It will do that because R is not just a statistical software, it is also some kind of almost programming language. Am I right in saying that? Yeah. So you can do programming with that. Again, I shouldn't say that, but I have now learned how to write exam questions in R. And it creates, for example, not just one exam question. Last year, I have written 125,000 exams with this program suitable for Moodle. So there's no collusion. Not one, not two people will ever have the same exam question. Good boy, R. I have also put up some sort of support documents. For example, how to include vectors in R, and I will talk about that in a moment. And on my wonderful website, I have a whole host of R snippets that you can look at for all sorts of statistical problems. These R snippets are actually taken from, see if I can find that. From a book that I put together, Data Analysis for Bioscientists with Excel and R, available on Amazon, shameless plug, I don't care. And it's also on the website. There are all these snippets. Let me see. So here are lots of sort of statistical problems that you might encounter. And This is basically what our code might look like. Very simple, and I just show you in a moment what this looks like. Let me go back to this one here. So you find these R snippets, and please do feel free to use them. They are there for you. They should all work. If you come across as something that doesn't work, let me know, please. So here is a very simple R code. And it allows you to make comments. That's always a good idea, to write down what something does. You know this stupid programmer joke? Only God and I know what this code is doing. 3 days later, you look at it and you think, okay, only God knows what this is doing, because I've forgotten what it does. So you can comment, you have this hash in front of it, and that indicates that this line is to be ignored by the program. It just allows you to make comments. So here you have what is called a vector. This is a data set. You assign a name to this data set. So in this case, I call it observed, but you can call it whatever you want. Rule is there must not be an empty space in it. So what you see here, for example, I want to calculate the median of the observed. So I do an underscore. There's no empty space in it, in the variable name. The variable is then assigned with this sort of backwards arrow. That's the smaller and minus arrow that you do on your keyboard. Some people use an equal sign. It works most of the time, but you immediately see who is a newbie because they use the equal sign, and hey, you want to come across as professional, right? So you do the backwards space. And then you have this vector annotation where you have this little c. The c means, or the program interprets c as put them together, concatenate. And here are your data. So we have 35, 20, 23, and 22. And these are the data that we want to analyze. So we can, for example, ask the program to analyze and calculate the mean of these 4 data points. So what I do here is mean observed is assigned to, and I say, calculate the mean of this observed variable here. Calculate the mean of 35, 20, 23, and 22. I can do the same with the median. I can say, calculate the variance, please. You see, here I call the variable variance observed. Make the variables as intuitive for yourself as possible. I have lots and lots of programs of these R snippets where there is just X, there's Y, there's Z, there's AA, there's XXX. And you sit there and you think, what the hell is XXX? And I didn't document it. Only God knows what this code actually does. So make it easy for yourself. Call it something that makes sense. So we've assigned these variables. We can do a standard deviation, for example. And the abbreviation for standard deviation is SD. Here the abbreviation is var. median, mean. Actually, R has an excellent help function. If you don't know what something does, you can put in question mark and then an abbreviation, or you can give you can have a list of things that that are used by R for certain purposes. So mean, median, variance, standard deviation. These are built-in functions, and you don't have to do anything. You just use them as they are. You can do more complicated things. So if you want to, for example, calculate a 95% confidence interval, you can do a little bit more complicated things. So for example, you can ask R to tell you R to tell you how many data points do I have in my original observed sample. So there were 4 data points. So you say here, n, that is, I call that the sample size. I could call it sample size. In this case, it's pretty clear to me what it is. It's n, the assignment. And then I say, give me the length of the observed data that I had up there. 1, 2, 3, 4. So if I then would ask n, give me n, it would return 4. I then can do some calculations, and you can, if you want, really use R just as a glorified calculator. You can say, for example, calculate 3 plus 5. Or you can say, give me the square root of 148. Something like that. Square root is actually abbreviated by SQRT. And here we would have square root brackets n. This n refers to that. And here the length would be 4. So here we would have square root of 4. Some things are a little bit more sort of not immediately intuitive. So QT, for example, will calculate the t-value or t-test score under certain conditions. What happens if you make an error? For example, you forget the assignment arrow, or you call this one here M instead of N. The nice thing about R is that it will tell you immediately and will say, sorry, no can do. There's an error. And it usually will give you even the line number where this error occurs. So you then can go back and say, oh, bugger it, I put in an M instead of an N. We'll just simply correct that. So what you then do here is you also can then have the output of the results with this list function, mean, median, variance, standard deviation, and confidence interval. You press the run button. And voila, you get within a split second, in this case, you get your results. The mean is 25, median is 22.5, variance, standard deviation, and you get a nice confidence interval. So the data, the estimated confidence interval for the population mean would be somewhere between 14.2 and 35.8. And you can do this calculation. That is sort of the standard version of R. But for more sort of interesting things, you can install what is called packages. These packages are little additional programs that you can download from the repository site. And if you go into RStudio, that's the interface, there is under the Tools menu, you can say Install Packages. And if you click on that, it will open a window, and you then can enter the name of the package that you need to install or want to install, and R will take care of that. It will download it and make sure that everything is correctly linked. And these additional packages can do additional things. So for example, the package ggplot2 will allow you to plot data as a scatter plot, as a bar chart, as box and whisker plot, things like that. And you can really nicely modify everything, text size, color, everything can be modified with this ggplot2 package. You have to tell the R program, the GP again, you have to tell the program, you have to tell R that you want to use this package. So you have to install the package in the first place. And then you have to initiate the package. And the command for that is library ggplot2. Do not make the mistake that I did when I started with R. I thought, instead of, installing the packages that I need, I just simply say install all packages. Yeah. That didn't work because there are over 150,000 packages that do different things. You never use them, the vast majority. And each package is, can be up to 100 megabyte. So your hard drive gets very full very quickly. So be selective what you install. And you can deinstall packages if you want. And then reinstall them, absolutely fine. R and RStudio will also tell you if there are new versions, and you can say update. Sometimes you need to update because then the packages are written for the newer versions and won't run on old versions. R is predominantly a statistical software, but you can do beautiful bioinformatics with it, sequence alignments, phylogenetic trees. You can do a lot of analysis. So for example, if you want to analyze whether two growth curves are the same, there's a package called growth that allows you to analyze growth curves and say, are they statistically similar? Are they different? So R has a lot of features, and I can really only encourage you to try and install it and play around with it. Any questions? Are you happy? Yes. Okay. What I would do is you can, for example, put in Google or in ChatGPT R packages for phylogenetic trees. Yeah. Very often, the packages have example data included, and in the help function of R, there are these examples then that you can look at and say, okay, this is sort of the syntax that I need to use in order to make the phylogenetic tree. The other thing is what's absolutely fantastic also, there is a very active R community out there. And there are lots of forums, you know what I mean, where you can ask questions. I have a problem with that. And usually within a couple of hours, you will get an answer saying, no, you need a different package, or you forgot a bracket in your code or something like that. The other alternative is what you can do is you can, for example, take this code here and put it in ChatGPT. If it doesn't run, put it in ChatGPT and say, ChatGPT, here is the code. I get this error message, and you will get an error message then in the console. I get this error message. Can you please fix the error? And in, I'd say, 50% of the cases, ChatGPT will be able to fix it. Sometimes it doesn't, and that's hugely annoying, but c'est la vie. Make sense? Great stuff. Use it. It's free. Invest a few hours at the beginning installing it and then play around. And you will have very little trouble then with statistical analysis. Any further questions? I see a few very tired faces. Thank you very much. I hope you enjoy your project, and I'm sure I will see you around. Thank you. I just want to ask 2 questions.